Thank you so much for joining this lesson. We're going to continue with the Kema Joint Examination 2025. We've already covered the section 1 of this. Those who have been careful, you discover that every question in the section 1 is already uploaded in this platform, Shifting Grades Online School. So kindly follow up with what we are doing. If you have not seen the section 1, every question bit by bit, please take your time to watch. So this time round, we will be on the section 2. Remember, our consultation line is 0704153366. So when you consult us through this line, then you'll be in a position to see everything that we are doing. Number 17, which is on statistics. The data below shows the lengths of leaves in millimeters. So we have the lengths in classes, the number of leaves with given lengths. Then part A, using assumed mean of 59.5, calculate part A, the mean length. Then part B, the variance. Part 3, the standard deviation. Then later we are to find the percentage of leaves that has a length of 69.5 millimeters and above. So let's begin. Allow me first display the data in a different way. We are already having the classes, so I'll rewrite them here together with the frequency. Then for every class, now I will have to write the midpoint. Then after the midpoint, now we can check at the deviations of each midpoint from the assumed mean. Then after that, we get the product of each midpoint and the deviation. Yeah, then deviations squared that way. And because of the last part, we shall require the cumulative frequency. So we need a lot of columns for this particular question. A lot of columns. Yes. So let me start by the classes. 25 to 24. 25 to 34. Then from that, we go to the next class, which is 35 to 44. 35 to 44. Then after that, we shall proceed to 45 to 54. Yeah, 45 to 54. 55 to 64. Remember to subscribe to this platform. Remember also to share the link with your friends. 65 to 74. Then we have 75 to 84. And finally, we shall talk about 85 to 94. 85 to 94, that way. So these are now the classes. Yeah, those are the classes. So there are a lot of quantities to be calculated here. And I want you to follow through very keenly. The frequencies, which is number of leaves, are already there. So frequency F, 9, 12, 55, 68, 32, 18, and 6. So I've just placed them in their respective classes. Now, the first thing that I was telling you I have to come up with is the midpoint of every class, midpoint X. Now, you're supposed to know that a midpoint is the value that is going to represent all the classes. So that is what we're going to come up with very quickly so that we may save time. For us to get midpoint, we have to add the limits, then take the average. 25 plus 34 over 2. That will give us 29.5. Then 35 plus 44, and we divide by 2. 39.5, 49.5, 59.5, 69.5, 79.5, and 89.5. So we are having all the midpoints now. After getting all the midpoints, let's now talk about deviation of every midpoint from the assumed mean. Every midpoint minus the assumed mean. So we start by taking 29.5 minus the assumed mean of 59.5. So this will give us negative 30, then negative 20, negative 10, 0, 10, 20, 30. Those are the respective deviations for the respective classes. After this now, allow me to calculate FD. Now each frequency times the deviation. So I begin with negative 30 by 9. This is negative 270. Then we can go to negative 240. I'm using 12 and negative 20. Then 55 and negative 10. That will give us negative 550. And the next should be 0 times, automatically becoming a 0. 10 times 32, 320. 20 times 18, this will give us 360. Then finally, be having 30 by 6, which is 180. Yeah. After this now, let me talk about sum of FD. So when I add up everything, I'm going to get negative 200. Getting 200 there. That is it. So with this now, we can find mean. At that point now, the mean can be calculated, which is Roman 1. Mean of X is usually given by assumed mean plus the mean of FD. Should be summation of FD, summation of F. So because we are having the column for F, we can also get summation of F by getting a cumulative frequency column here, whereby we start by 9, which is the first frequency, then plus 12, that becomes 21. Then 21, we add the next, which is 55, giving us 76. 76 plus the next, which is 68. This gives us 144. 144 plus the next, which is 32. This will give us 190. For 194. No, I think there's something we are skipping. When we take 76 and we add 68, I'm getting 144. Then 144, I add 32, I should get 176. 176. So that 176 plus 18, that now gives me 194. Then 194 plus 6, this is giving us 200 that way. So if cumulative frequencies are totaling to 200, then it means the summation of F is also 200. So we need 59.5, the assumed mean, plus negative 200 out of 200. So this will be -1. And with a -1, the final answer shall now settle at 58.5. 58.5. So now we can proceed to Roman 2, whereby we are supposed to get variance, which is abbreviated S squared. Now, variance will be given by the summation of FD squared divided by summation of F. Then this one we subtract summation of F of D out of summation of F. Then this now should be squared that way. That means, again, we should take a step of obtaining another column for FD squared. It is D alone which has been squared. Therefore, now we multiply 9 by -30 squared. -30 squared. That will give us 8100. Then the next should be 12 multiplied by -20 squared to give us 4800. The next should be 55 multiplied by -10 squared. So I'm getting 5500. After that, let's talk about deviation is 0. So 68 by 0 squared, it will just be 0. Then 32 by 10 squared, and that will give us 3200. Then the other one is 18 and 20 squared. That's giving us 7200. Then 6 and 30 squared, this is giving us 5400. At this point now, we can talk about summation of F of D squared. So when we add up everything here, we shall get 34,200. 34,200. So now getting back to the formula, I will substitute 34,200 out of 200. Then I subtract -200 out of 200 squared. So I'll be having 171 minus 1, because -200 over 200 will become -1. But after squaring now, the negative cancels. So we'll get 1. So this one is giving us 170 that way. That is our variance. Then we go to standard deviation now, which is the square root of variance. So this one should be the square root of variance. So we need the square root of everything that we have worked out. The square root of this. But now you should remember that we have already computed that. So we just need the square root of 170. Remember, this can be our answer in third form, but we can still proceed and ensure an accuracy of 4 significant figures. Yeah. So we have now done the part A, which is having 3 parts, completely done. We proceed now to part B. Find the percentage of leaves that has a length of 69.5 millimeters and above. Mark the word "and above." So we are going now to use percentiles. And it is good for you to know that the formula for percentiles is usually given as a given percentile. Let's say nth percentile. This one will be given by the lower boundary for that percentile. Then here we shall have the nth percentile now. The n percentile So the n percentile of total frequency minus cumulative frequency just before, divide by frequency of this particular class, and this should be multiplied by the class length of the particular class. So a certain percentile is already given as 69.5. This one will be given by lower class boundary. So getting back to our statistics now, get back to the table, 69.5 will lie at a given class, and we must identify that class. So the unknown percentile is lying in this class, 65 all the way to 74. So when we start substituting now the lower boundary, it should be 64.5. 64.5, 4.5 plus. Assuming that the value worked out here is x, then we should subtract from x the cumulative frequency just before this class. So cumulative frequency just before this class is 144. 144 over frequency for this particular class. So this particular class is having a frequency of 32, yeah? Then a class length equivalent to, let me check the class length. From 64.5 all the way to 74.5. So the class interval is equivalent to 10. A class interval of 10 that way. So with this, we can find x. Yeah, we can find x. So it's good for us to subtract this value, 69.5 minus 64.5, giving us 5, which is equal to x minus 144 out of 32, multiplied by 10 at this point. Therefore, we can remain with x minus 144 by multiplying by 32 over 10. This is going to be 16. So 16 equals to x minus 144. So that the value of x now becomes 144 should be added to 16, giving us 160. So a certain percentile is equivalent to 160. So from 0 to 160, we have a length of 69.5. But now we need the percentage of leaves which are having the length of 69.5 and above. Therefore, now the total leaves are 200 according to the total frequency. They are 200. Now with that value, we should know that from 0 to 69.5, from a length of 25 all the way to 69.5, we have 160. So that means those with above are only 40. This one was very technical now. So you needed to find 40. But now after getting 40, now you ask ourselves, which percentile is this, or which percentage is this? So 40 of 200, when expressed as a percentage now, this one will give us our answer, which is equivalent to exactly 20%. Yeah, 20%. So a student is supposed to be very careful with such an analysis. Very careful. So it's my hope that you will be able to follow through and understand this kind of a setting. It's also good for you to know that statistics is a widely evaluated topic, knowing that in paper 1, we have statistics 1. Now in paper 2, we are having statistics 2. Therefore, prepare on statistics. The other thing that you're supposed to widely prepare on is commercial arithmetic, which is so broad. It is both in paper 1 and also in paper 2, and that's why we have number 18 on taxation. The table below shows income tax rates in a certain year. The monthly taxable income is shown. Then we have the tax rates, which are given as percentages. Onjera is a civil servant and earns a basic salary of 34,800 Kenya shillings, medical allowance of 2,400 Kenya shillings, house allowance of 10,000 Kenya shillings, commuter allowance 7,200 Kenya shillings, and a non-taxable allowance of 12,000 Kenya shillings. Could be this is now a hardship allowance. In most of the cases, the hardship allowance is never taxed. So this one is non-taxable. He has a personal tax relief of 1020 Kenya shillings and also gets relief equivalent to 10% of the premium paid. If he pays monthly insurance premium of 2,700 Kenya shillings, calculate in part 1, Onjera's monthly taxable income. So monthly taxable income should be given by the basic salary, 34,800, plus all taxable allowances, medical 2,400, house allowance 10,000, commuter 7,200. Yeah, commuter allowance 7,200. So I'm getting 54,400. 54,400 that way. Part B, find the net tax paid by Onjueras. This gentleman now is going to pay some tax. Now we are going to follow the taxable income that you've obtained for us to tax. So let's check. From the first band, we have the taxable income of 14,200. So 14,200. This one is done at a rate of 10%, and it will give us 1420 Kenya shillings as tax. Then in the next band, now we are supposed to take 26,700 and we subtract 14,200. You see, this is giving us 12,500. 12,500 in the next bracket, that is the second bracket, and the rate of taxation here is 15%. So this will give us a tax of 1875 Kenya shillings. Then in the next bracket, which is the third bracket, we talk of 39,200. We subtract the previous limit of 26,700, and this will give us the same amount, 12,500. 12,500. This one now is being taxed at the rate of 20% per month, giving us a tax of 25,000. After this, we can talk of the fourth band, whereby we have 51,700. We subtract the previous limit of 39,200. That will give us again 12,500 at the rate of 15. 12,500 at the rate of 25, that is, % per month. And this will give us a tax equivalent to 31,250. 3125, that is. Yeah, 3125. Then after that now, anything which has not been taxed should lie in the last bracket. So we take the total, 54,400, and we subtract the limit here, which is 51,700. So that we know in the last bracket, we shall tax 27,000. So the untaxed money is 27,000, and that will be taxed at the rate of 30%. So 27,000 at the rate of 30% per month, this is going to be 810. So when we add up all this, the value that we are getting is called the gross tax. Gross tax, or the total tax, which is obtained from addition of now the amounts from the individual brackets. So when we add up all this, we shall get 9730. 97.30 Kenya shillings. Then after this, we go back to the question. We need the net tax, not the gross tax. So for us to get the net tax, we have to subtract all the reliefs. Minus reliefs. So net tax, also known as the payee, will be given by gross tax minus relief. Now, this gentleman is been showing several reliefs. We have a personal relief and also a relief due to the premiums that he pays. So we can see, we can get the reliefs at this point, whereby we are having 1020. Then we are also having another relief equivalent to 10% of the premium paid. So 10% of premiums equivalent to 2700, because these are the premiums paid. So this will give us now total reliefs equivalent to, let me check 10% of this, 270. So 1020 plus 270, this is equivalent to 1290. 1290. So in this case, now we shall get all the gross tax and we subtract 1290. So the net tax now shall be 8440 Kenya shillings. 8440. Or rather, 8,440. So that is the tax paid by Onjwera. Now let's get to more instructions in Part C, whereby we are told that if Onjwera pays a loan of 8,000 Kenya shillings every month, affordable housing levy of 1.5% of the taxable income, and SHA fee of, SHA is a social health authority, 1,805 Kenya shillings, find is net monthly pay. So how do we get net monthly pay? Net pay is usually given by gross income minus all deductions. All deductions is everything that he pays. So what would be the gross income? Gross income is everything that he earns. So we are already having a taxable income, 54,400. And we are also having a non-taxable allowance, non-taxable allowance of 12,000. So that will be now the gross income. Then we subtract all the deductions. Subtract all the deductions. The first deduction is the payee that he pays. So the payee, 8440. What are other deductions paid by Onjwera? Other deductions include, from the statements there are premiums 2700. Else, we have a loan repayment, 8,000. Else paid, 1.5% of taxable income. So 1.5% of 54,400. That one goes to housing, the housing levy, plus SHA, which is 1805 per month. So now we'll be having, when we get 54,400 and we add 12,000, I'm getting a gross income of 66,400. Then all deductions now are totaling to 21,761. All the deductions made from Monjera's income. So from this, I'm going to get a net monthly pay equivalent to 44,639 Kenyan shillings. So that's how we work it out. A very good question indeed. Please remember to review, remember to revisit, and get to understand everything and how it has been done. Consultation line remains 0704 153366. You can WhatsApp or send a message. Now, number 19, question on longitudes and latitudes. A ship sails from point A, which is 0 degrees, 70 degrees in the west, due north to another point B, which is 25 degrees on the north, 70 degrees in the west. So it's flowing along the same longitude, 70 degrees in the west. Then due east to a point C, 25 degrees north, 12 degrees in the east, and finally, a further 1800 nautical miles due east to point D. Part A of this question, calculate the total distance covered in nautical miles. Total distance covered in nautical miles. Now look at this. I'm going to first sketch the location of the several places. This one is a prime meridian, which is 0 degrees. 0 degrees equator. Start well placed. 0 degrees equator. Then now we can start. The first place A is on the equator, 70 degrees in the west. So this is 70 degrees in the west and on the equator. So A is there. This ship is going to sail upwards until 25 degrees. So this is going to be our point B, and this will be 25 degrees in the north. Still on 70 degrees in the west. After that now, it shall move towards the east now until it is on point C, 12 degrees in the east. 12 degrees east. So this becomes our point C. 12 degrees in the east along the latitude, 25 degrees in the north. Finally, due east to D. So it shall move further to the east. So it will continue along the same latitude and proceed until it is at D. And proceed until it is at D. Until it is at D, which is still to the east. We need the total distance. So first, let's get distance from A to B. This one is along a great circle. So distance along a great circle in nautical miles shall be given by 60 multiplied by the angle difference. So 60 multiplied by 25. 60 by 25, right? I hope you understand that. 1500. 25 is from east, from 0 degrees equator, from the equator all the way to, this is an arc, AB. Let me draw it well. This is an arc, AB. That's an arc, AB. So from 0 degrees all the way to 25, there will be an angle of 25 degrees. So we are using the angle difference of 25 multiplied by 60 for us to get the distance in nautical miles. Then from B to C, the distance is along a small circle of a latitude. So it will be given by 60 multiplied by alpha, the angle difference, cosine of the latitude, where the two places are. Therefore, we shall talk about 60 multiplied by the angle difference now From B, let me show you the arc and how it is. From B along a latitude all the way to C. Remember, we have the prime meridian here. We have the prime meridian there. So we have an angle here and an angle here. From prime meridian to B, we have 70. And from prime meridian to C, we are having 12. Therefore, the angle at the center of that small circle now shall be 82. It shall be 82. So we'll talk about 82 multiplied by the cosine of the latitude where the two places are. This is latitude 25 degrees in the north. So when you work out, you get 44.59 nautical miles. Okay. Now we are having a further movement now from B, okay, from C all the way to D. The distance is already provided in nautical miles. So total distance moved shall be the addition now. We talk of 1500 plus 44.59 plus 1800. And this is going to give us exactly 77.59. Nautical miles. So that is the distance in nautical miles. We can proceed to the part B. If the whole journey took a total time of 300, find its average speed in knots nearest one decimal place. So speed in knots is given by distance, which must be nautical miles, divided by time, which must be in hours. Nautical miles per hour is named knots when it comes to navigation. So the distance here is 77.59 out of 300, and this shall give us 25.9 knots. Yeah, that is now to the nearest one decimal place. In part C of this question, we are taught to find to the nearest degree the final position of the ship. So this ship is going to move from, this is a 12 degrees in the east, and continue moving further to the east to another point D, whereby the latitude is, this is 12 at point B, at point C. Then for it to go to C, it is moving through, no, we can get the angle there. It's moving through a distance of 1800 nautical miles to point D along the same latitude of 25. So remember, distance in nautical miles is usually given by 60 multiplied by the angle difference, cosine of the latitude where the places are. So 1800, the distance, equals to 60 alpha, cosine of the latitude, which is 25 degrees. So we can remain with the angle difference by taking 1800 divided by 60 multiplied by the cosine of 25, and this is giving us 33.10 degrees. So that is the angle difference from point C to D. And remember, we were already at 12. We were already at 12. We need this one in the nearest degree. So this can be now written as 33 degrees that way. So remember, we are already at 12 degrees in the east. And now we are moving further through an angle of 33. That means point D, the longitude of D shall be 12 plus the 33 covered, giving us 45 degrees in the east. Therefore, the position of D is going to be 25 degrees in the north, 45 degrees in the east. Remember, the positioning is supposed to be given with reference to the latitude, then the longitude, written as a coordinate, and it must be in that order, in that particular order, without any variation. So that's how we work out the question on longitudes and latitudes. Together, we move to number 20. Complete the table below, giving your answer, giving your values correct to 2 decimal places. 2 decimal places. All right. We can see already the provided values are in 2 decimal places. Therefore, we are supposed to store the same by providing our values also in 2 decimal places. The first function is giving us the value of y as 3, the cosine of x. So 3, the cosine of 15 will give us 2.90. The next gap is at 45. So 3, the cosine of 45. This one gives us 2.12. Yeah, 2.12. Then the last gap at 120, 3, the cosine of 120. Now this gives us negative 1.5. So it should be negative 1.50 that way, so that we ensure the accuracy of 2 decimal places. Now the second function is for the sine of, look at it very carefully, for the sine of 2x minus 10. Therefore, I'm going to open the brackets just as it has been written. For the sine of, I open brackets. Now, I should have 2 multiplied by 0. Okay, the gap is at 30. So 2 multiplied by x, which is 30. Then we subtract 10 from this. And this is giving me 3.06. You are supposed to use your calculator very well in this case, very well. Look at the next gap, which is at 75. So we talk about, again, for the sine of, you open brackets, 2 multiplied by 75 minus 10. This is giving me 2.57. 2.57. Yeah, 2.57. Let me write the 5 well. 2.57 that way. Then at 105, 4 sine, open brackets, 2 multiplied by 105 minus 10. Now this shall be negative 1.37 to an accuracy of 2 decimal places. To an accuracy of 2 decimal places. So that is it. We are now through with filling the table. And now we are to proceed to the second part of this trigonometric question. Taking 1 centimeter to represent 15 degrees on the x-axis and 2 centimeters to represent 1 unit. 2 centimeters for 1 unit on the y-axis. Draw the graph of y equals to 3 cosine of x and y equals to 4 sine 2x minus 10 degrees on the same set of axes on the grid provided. So the grid is already provided here, and this is what we shall use. So it's my hope that you're going to follow very keenly in the plotting of the 2 functions on the same axis. 2 functions on the same axis. So let me start by doing the axis. The vertical axis, or rather the y-axis, is here. Then the x-axis. You check the x-axis very well so that you don't misuse the space. We can place it at this point. The x-axis there. Now with the axis like that, we can follow the instructions about the scale very well. So that from 0, we talk about 0.5, then 1. So 2 units are supposed to represent 2 centimeters for 1 unit. 2 centimeters, another unit. 2 centimeters, another unit. 2 centimeters, another unit. That way. Then on the lower axis, of course, we also do the same. Yeah, that way. So now we are having the axis, which is vertical, well labeled. Then on the x, we talk about 1 centimeter for 15. So if it's 1 centimeter for 15, then from 0, we are going to 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, like that. Yeah, that's how it should proceed. I want to write 45 well. Yeah, that way. So the axes have been labeled. And now the next thing is to plot now. The two axes on the same, the two graphs on the same, the two functions on the same axis. So the first one, the coordinates are 0, 1, 0, 3, 0, 3. So 0, 3 means at this point. The next is going to be 15, 2.9. So 15 and 2.9. 2.9 is slightly below 3, 2.9 there. 30 and 2.6. 30 and 2.6, so slightly above 2.5. 45 and 2.1. 45 and 2.1. That is the point. 60 and 1.5. 60 and 1.5. So 1.5 is there. 75 and 0.8. I'm trying to round off to the accuracy which can be plotted on our scale. So 75 should go with 0.8. Yeah, 75 and 0.8. So 0.8 for 75, slightly below 1. 90 and 0. We talk about 105 and negative 0.8. Negative 0.8 is somewhere almost at negative 1. Then finally, we are having 120. So 120 at negative 1.5. So 1.5 negative is at this point. So we are having all the points well plotted. So now we can do the curve by joining all the curves. We just join all the points until we form a very smooth curve. Very smooth curve. So let me come up with the curve very smoothly. Very smooth curve. Remember to subscribe for more updates, for more tips in mathematics. So the curve has been well joined, and this curve can be written that it is the curve y equals to 3 the cosine of x. Yeah, 3 the cosine of x, that two. Now we go to the second curve. Yeah, the second curve, let me plot using a green. in the second curve. So the second curve now, we're going to start with 0 and negative 0.7. 0 and negative 0.7. So negative 0.7 shall be here, that way. Then 15 should go with 1.4. So 1.4, just before 1.5, we go to 1.4. Let me plot the coordinate very well. 1.4 that way. 30 with 3.1. 30 with 3.1. So 3.1, slightly above 3. That way. We're also talking about 45 and 3.9. 45 and 3.9, yeah. 45 and 3.9. 3.9, just before 4. That way. Then 60 goes with the 3.8. 3.8 that way. After 60, we go to 75, which goes with 2.6. 75 with 2.6, 2.5, so 2.6 is here. 90 goes with 0.7. 90 goes with 0.7. So 0.5, 0.7 is here. 105. 105 goes with negative 1.4. Negative 1.4. Just before 1.5, we have 1.4. Then we can also talk about 120 and negative 3.1. 120 and negative 3.1. So negative 3.1 should be somewhere here. Yeah, sorry for that. You're not supposed to plot outside the domain which has been provided. And instead of repeating everything, you should understand that the x-axis should have been plotted slightly above where it is to give us space for the negative sides of y. Okay, so we are supposed now to join these points until we get a very good curve. Until we get a very smooth curve from these points. They have already been plotted. They are suggesting a smooth curve. So ours is now to join them smoothly in a very good order. Yeah. So I'm going to turn very well. That way. Turning should be very smooth. Remember, when you have two coordinates at the topmost point, yeah, 2 points at the topmost, you should then understand that none of them is the turning point. So you turn slightly between them, somewhere between them. This one is y equals to 4, the sine of 2x minus 10 degrees that way. So we have now the two curves smoothly plotted. Just look at them. A very smooth plotting, and I'm doing it on a screen. That means you can do it better with your pencil, well sharpened. You can do it better. That's all. Use your graph now. Let's check the questions now after that. Use your graph to find the values of x, for which this is the first function, and this one is the next function. So 3 cosine of x minus 4, the sine of 2x minus 10 equals to 0. This means 3 cosine of x, we can take now the negative 4 to this side so that you have 4 sine 2x minus 10. Now this means we want to find the values of x where the two curves are equal. And that means the points where the curves are intersecting. So the points where the curves are intersecting now can be interpreted very well from this particular curve. So I can have the first intersection. Let me check the first intersection. You can see the first intersection, and I want to leave the value of x. I want to check the value of x at that point of intersection. We know that 5 small squares, want to check that value. 5 small squares are representing 15 degrees. What about 1 unit? It shall represent 3 degrees. So if it represents 3 degrees, then we are talking about 27 at that point. So that will be 27 degrees. So the first x equals to 27 degrees. Then x will also be, we check another point of intersection for the two curves. So another point of intersection is here. At that point. So we read the value of x. From 90, we have 2 small squares to the point of intersection. Therefore, it's at 96. So x can also be 96 degrees. So those are the points where the curves are the same. Where the curves are the same. We proceed with the interpretation of the graph. Right. Carefully, we read the part D of this. State the amplitude of the graph, which is y equals 2. According to this, it's very good for you to know that the value of the amplitude is usually just before the trigonometric ratio is mentioned. So we talk about 3.00 or 3.0 units. But again, from the graph, we are though we are told to state, actually the instructions of using the graph are in part C. In part D, we've not been told to use the graph, though it's good for you to know how to use the graph in case the question is tied. But when you look at it keenly, we've just been told to state. This is a loophole for us to just pick the value from the function 3. But again, you can see that the highest where this curve can go is at 0.3. And if we had to proceed, we would have discovered that the lowest it can go is also -3 on the lower side. Therefore, we pick the absolute value, which is 3. Now, in the next one, we are told that the period of the curve, we state the period of the graph, the second graph, whereby the amplitude is here, and we can see that there is an angle here of 10. So in case we'd been told to state the phase angle, it could have been 10, the absolute of whatever is written there. So we are supposed to know that a period is usually given by 360 divided by the value just before x. So for this case, we are having 2 that way. So the period is 180. 180 that way. Yeah, 180. Very good interpretation. Very good interpretation. Something else that we could have used, assuming that we were told to use the graph to find the period, assuming that we were to use the graph, I want to show you how to interpret for you to get your 80 instead of using the function, because from the function we know that given y equals to a, the sine of kx minus or plus a certain angle there, we are supposed to know that from this general function that amplitude equals to the value of A. Then period T equals to 360 out of the coefficient of X that way. Then finally, phase angle. Phase angle equals to the absolute value of the angle at that point. So that's why we can state without going to the graph. We can state without going to the graph. But now assuming that part D was using the graph, find amplitude, find period. For the amplitude, I have told you it is the highest level it can go or the lowest the curve can go. But we pick the absolute value in case we observe the lowest it can go. Now, let me show you how to pick the period from the graph. So we can consider the point where the graph, let me consider the second curve, whereby from this point all the way until it is at the same point again. So you see that is from 6 all the way to 96. We are getting 90. We are getting 90. So now that we are getting 90, then we are supposed to know that this is half of a complete cycle. From 6 to 96, that is half a cycle. Therefore, it should move through another angle of 90 for it to cover a complete oscillation. So we need to take 90 by 2, and this will give us 180. So in case a whole wavelength had featured, we would have been in a position to read 180 direct. But now that a whole wavelength has not featured, then we interpret half a wavelength and we multiply by 2. So half a wavelength is going through an angle of 90, meaning that a complete wavelength would go through an angle equivalent to an angle equivalent to 180. So that's how we could have read it from the graph. That's how we interpret the curve. Remember, ladies and gentlemen, to subscribe to this platform. Again, remember that we are supposed to consult more through our line here. This is our hotline, 0704 15 3366. Our email is already here. .com. So if you love emailing, you can still reach us through the email attached. Our line, which is on the board, is also the M-Pesa line. We will appreciate your support. 21, a question from Sequences and Series. A very interesting question. Let's go through this question together. We are told that the second, 14th, and the 92nd term of an AP arithmetic progression corresponds to the first 3 consecutive terms of an increasing geometric progression, that's a GP. If the first term of the AP is A and the common difference D, but find a simplified equation of A in terms of D. In other words, we form an equation containing A and D, then we make A the subject. An equation of A in terms of D. That one is very specific. So you don't just form any equation and you leave it the way you want. You are supposed to have the equation of A in terms of D. Now let's proceed. Let's proceed in part B now. Part A, sorry. The second term will become the first term in a GP. The 14th term in an AP becomes the second in a GP. Then the 92nd term becomes the third. This means when we take the 14th term, 14 over second, we are supposed to get the same thing as when we get the 92nd term and we divide it by the 14th term. Because in a GP, we expect the terms to give us a common ratio. If a GP, for example, is 2, 4, 8, 16, 32, like that. When we take 4 and divide by 2, we are getting 2. When we get 8 divided by 4, we get 2 again. 16 over 8, we get 2. 32 over 16, we get 2. So the terms in a GP are usually related. At this point, it's good for students to know how to find nth terms in a given progression, be it arithmetic or geometric. For this case, we are needed to know how to find nth term in arithmetic progression, AP, whereby it needs to be given by first term, n minus 1 multiplied by the common difference. So let's follow through now this interpretation very carefully, because this is a common setting in mathematics paper 2. Okay, so the second term shall be a plus 2 minus 1 multiplied by d. This will give us a plus d that way. The 14th term shall be a plus 14 minus 1 multiplied by d, which is a plus 13d. Then the 92nd term, a plus 92 minus 1 multiplied by their known common difference, a plus 91d, that way. So these are the terms now, but when they are arranged following one another, they are going to form a GP. If they are forming a GP, then we can use that knowledge to conclude that knowledge should be used to conclude that in case we get the term here, 14th, a plus 13d, and we divide by the second term here, which is a plus d, then we'll get the same as when we get the 92nd, a plus 91d, divided by a plus 13d, that way. So this interpretation now should be used to conclude a few things. We can now cross multiply a plus 13d multiplied by a plus 13d, so squared, equals to a plus d multiplied by a plus 91 small letter d, that way. Then now we can expand a plus 13d squared. We are going to get a squared plus 26 AD plus 13 squared is equivalent to 169 D squared, that way. So this is the same as on the right hand side now. A multiplies everything in the second bracket, so it becomes a squared plus 91 AD plus D multiplies everything, so AD plus D again multiplies 91, so it shall be 91 D squared, that way. So from this, we can now group terms together. A squared and a squared shall cancel one another. Then now we can address 169. 169 and 91. So 169 minus 91, this gives us 78 D squared, equals to, on the right hand side, we are having 91 AD plus AD. So that's 92 AD minus 26, giving us 66 D. 66 AD, sorry. 66 AD. So with this, now we can adhere to the first instruction, which is finding a simplified equation of A in terms of D. So we make A the subject. To remain with A, we now divide 78 by 66. This is 1 and 2 over 11. The value of D. So A is given us the value of D because 1D is going to simplify. By D, 1. By D, the squared cancels now. So that's why I'm saying the value of A can be expressed as 1 and 2 over 11D at B now. Given that the value of A is 13, find the fourth term of the geometric progression. So let's say that the value of A is 13. So 13 is equivalent to 1 and 2 over 11D. So to remain with D now, we are supposed to divide through and get the value of D as 11. So if D is 11, then A can be found. If D is 11, then A can be found. And what is going to be A? 13. It's already given. So with this now, we can now find the exact terms. So the first term in this GP is going to be the second, this one, A plus D, which is 13 plus 11, which is 24. The second term is the 14th term, which is A plus 13D. A plus 13D means 13 plus 13 into D is 11. So I'm getting 156. Then the third term in the GP is going to be the 92nd term, whereby we need A, 13 plus 91 into 11, which is our value for D. So this is giving us 1014. Yeah, 1014 that way. So now these are the first three terms in the first three terms in the GP. Can we get the value of R? What multiplies one term for us to get the next? 156 divided by 24. Will it give us the same as 1014 out of 156? Will it give us the same? We can just confirm. 1014 over 156, I'm getting 6.5. 156 over 24, I'm getting 6.5. So the value of R is 6.5. And for us to get the fourth term, it means we need the third term multiplied by the ratio, the common ratio. So 1014 by 6.5, this is giving us 6591. 6591 that way. Yeah, 6591. Very simple. 6591. All right, that is a technical approach to the question. Can I advise learners to also know how to get any of the term in a geometric progression? Any of the term is generally given by A R power n minus 1. So in case the term was very big, such that it is not the fourth, which is just the next, then this one should have been given easily by taking A, the first term, which is 24. Yeah, the first term is 24. It is now for the GP, not for the AP. So the first term in the GP is 24, not 13. Then R, which is 6.5, R should be multiplied by N. We need the fourth term as 1 that way. So 24 should be multiplied by 6.5 raised to power 3. And this one can be given as 24 multiplied by 6.5 cubed, giving me 6591. So it's good for you to know the formula. So this is a second approach, alternatively. So a learner can still approach it that way, and you find yourself with the right answer. Very simple. Now, are we supposed to check part C together? I would request your attention here. Determine the greatest number of terms for GP, or for the GP above. That would give a sum greater than 50,626.5. Sum of a given number of terms is usually given by A into R power n minus 1, R power n minus 1, that way, divided by R minus 1. Therefore, the sum is known. 50,626.5. This is equal to the first term, 24, into R, 6.5, raised to unknown n, then minus 1, out of R, 6.5, minus 1. That way. So now to simplify this one very quickly, I can take 24 and I divide by 5.5. That's 6.5 minus 1. 6.5 minus 1 is 5.5. So 24 divided by that, I'm getting 4, and 4 out of 11. So we can proceed now, or have it this way. Let me arrange everything. You know, I may overuse the calculator, then I lose some people on the way. This is 24, 6.5 power n minus 1 out of 5.5. So I'm taking, for this part, multiply by 5.5 over 24, and also this part by 5.5 over 24. You see, it shall cancel from this side. So I'll be having 6.5 power n minus 1. Then on this other side now, I'll be having 50,626.5. I multiply by 5.5 over 24. Then this is giving me 11,601.90625. Yeah, 90625. That thing. With this knowledge now, we can add 1 for us to remain with 6.5 power n. Now 1 should be added to the left, so that this becomes 11,602.90625, that way. So we can introduce logarithms on both sides. The log of 11,602.90625 equals to the log of 6.5 power n. So I can drop n here according to the laws of logarithm. Then here I'm already having the log 11,602.90625. At this point now we can remain with n by dividing through. So the log of 11,602.90625 divided by the log of 6.5. You see, this is giving me exactly 5. Exactly 5. Therefore, the number of terms that would give a sum equivalent to this is 5 terms. But what is a question? The question is, determine the greatest number of terms for the GP that would give a sum greater. So for the sum to be greater than this now, then the number of terms now are supposed to be 6. Because when they are 5, they would give a sum equivalent to this, yet the examiner needs a sum greater than this. So we need the 6th term. So that is it. Thank you so much for following. Remember to subscribe to this platform and also to share the link with your friends. Thank you so much. See you next time for continued revision.